Another way of expressing roots is with rational exponents. So what this will look like for rational exponent, this is when you have a fraction as the exponent on your variable or number. In this video, we're just going to focus on having 1 in the numerator and then divided by some value n. How that would translate into radical form is that you'd have the base of the exponent would be underneath the radical, and then what's showing up in the denominator there links to the level of root that you're taking. Now, we have this 1 in the numerator here, and in the next video we'll look at what happens when we change that number. Really where that 1 is coming in the radical form is right here as an exponent on x. So with that, we don't really need to worry about in this video because an exponent of 1 doesn't change anything. So when we have our radical form, we look at the denominator, and that tells us what type of root we're taking. So for example, if we see x with an exponent of 1/4, that 4 in the denominator means that we're taking a root at the 4th level. So this is a 4th root of, and then what goes underneath is just the base of our exponent. So let's look at just changing between these two forms. So we're going to take each of these and change them into a rational exponent. So this value 6 underneath the radical, so that becomes the base of our exponent. And then 3 would be our denominator for the exponent. So this would be 6 to the 1/3 power. For this case, this is actually similar to our example up above there, where we would have this base x, and then because it's a 4th root, we would have a 1/4 exponent. And then this last one here, we have 26, and what we would just want to think about is even though there isn't a number there, really this is a square root, so there's technically a 2 there, so this would be the same thing as writing 26 to the 1/2 power. So we're getting this other form of working with these roots. How these are going to come into play is that we can use our exponent properties with these. So if we want to simplify values that are difficult to simplify in radical form, what we can do is change it to this exponential form and then apply all of those properties that we talked about with exponents. Let me throw in one more example here. Let's say I was taking the 5th root and just to have a more complicated expression underneath, let's say it was 2xy squared. So changing this to exponential form, everything that's underneath the radical would be the base of the exponent. So what I would do is group that together in parentheses. So I'd have my 2xy squared all together, and then the exponent is coming from basically this radical symbol with that 5 there. So we would have a 1/5. But then, and we won't do this here, but we could simplify this further by using our product rule and power to power. So we could simplify this further, but we'll just leave it like that for now. So if we're given values in our exponential form, what we can do is change it to radical form to simplify. Because if this is your first time seeing these, it might be difficult to think of how this would simplify to 8 unless you change it to your radical form. So with that exponent of 1/2, that's my square root, and then 64 is the base of the exponent, so that would go underneath the square root. So this is really the square root of 64, which would be 8. So in math, we'll see this exponent of 1/2 come up quite a bit, and it's just good to get used to thinking that as a square root that we're taking. For this -27, since the -27 is in the parentheses there, it's all under the exponent, so that's going to go underneath our radical. So we're going to have a radical with -27 underneath, and then because it's to a 1/3 power, this is going to be a cube root. And then we just simplify as we would with radicals. So cube root of -27 would be -3. And again, just as a refresher, that would be because if we took -3 in parentheses and cubed it, that would give us -27. So again, that level of root tells us what exponent we would need on our value in order to get what's underneath the radical. With this one here, we're taking a 4th root of, and then -16. Now with this case here, we have a negative number underneath and we're taking an even root, which we cannot do. So if you see an even number show up here and a negative number show up underneath, then our answer is that it is not a real number. So be careful of those. So that'll come through when you have these even denominators showing up in the exponent on top of a negative number. Now with this one, notice that the negative isn't inside of parentheses. So what could help with this case is thinking of this as -1 times 100 to the 1/2. It's like the negative is doing its own thing. So it's just going to stay out front. But this exponent of 1/2 is only affecting the 100. If there were parentheses, then it would be a square root over all of that. But because there aren't parentheses, the square root is only going to be over 100. So this would be like the same thing as -1 times the square root of 100, which the square root of 100 is 10. So this would be -10. Now with these, we can check these with the calculator. Let's look at this last one. If I typed it in exactly as I saw it on the paper without parentheses, so -100 raised to a power of 1/2, there's our -10. So you can plug in these rational exponents and see how they simplify with the calculator without using your root symbols.